40,000 years ago, the night sky looked different. Not because the stars had changed, but because there was nothing between you and them. No city lights, no street lamps, no phones glowing in the darkness. Just you, the fire, and 10,000 points of light scattered across an infinite black canvas. And somewhere in that darkness, prehistoric humans made a discovery that would change everything. The stars weren't random. They moved in patterns, perfect, predictable, eternal patterns. This wasn't just a pretty observation, it was a survival tool more powerful than any spear, because once you understood the sky, you understood when. When to migrate, when to plant, when winter was coming, when the herds would return. But here's the mystery. How did they figure this out? They had no telescopes, no charts, no mathematics, no writing, just eyes, memory, and something that emerged around this time. Pattern recognition on a cosmic scale. This is the story of humanity's first science, and how the stars taught us to think. Before 40,000 years ago, humans looked at the night sky, but they didn't see it. Not the way we did. Neanderthals had brains as large as ours, some were even larger. They were intelligent, tool users, they buried their dead with ceremony. But something was different in how we processed information. Around 40,000 years ago, Homo sapiens underwent what scientists call the cognitive revolution. Our brains didn't get bigger, but they got more connected. Specifically, the connection between our visual processing centers and our abstract reasoning centers strengthened dramatically. This meant we could do something unprecedented: see patterns that weren't immediately obvious. When you look at stars, you don't see a bear or a hunter or a dipper. You see dots of light. But your brain creates the pattern. It imposes meaning on randomness. This is called apophenia, the tendency to perceive meaningful patterns in random data. In modern life, it makes us see faces in clouds and hear words in white noise, but 40,000 years ago, it let us see something real. That the stars weren't random at all. They repeated night after night, season after season, year after year. The same stars rose at the same times, the same patterns wheeled overhead, the same celestial markers appeared before the same earthly events, and once you noticed that pattern, you could predict the future. Not through magic, through observation. This knowledge could be taught, passed down through generations, refined over centuries, and it transformed us from reactive animals into the first species that could plan for events that hadn't happened yet. Without light pollution, the Milky Way isn't a faint smudge, it's a river of light, bright enough to cast shadows. To prehistoric humans, the night sky wasn't a distant thing you glanced at. It was an ever-present companion, a living calendar. And they learned to read it with extraordinary precision. The first pattern they noticed was the most obvious. All the stars rotate around one fixed point. We call that point the North Star today. They called it many things: the nail of the sky, the fixed one, the anchor. If you watch the sky for even one night, you'll see every star appears to move. Except one. That star never moves, and it's always in the same direction. This was humanity's first compass. If you could find that star, you always knew which way was north, which meant you could navigate at night, cross unfamiliar territory, find your way home. But the real breakthrough was understanding that the stars also told when. Different constellations appeared at different times of year. If you saw Orion rising at sunset, you knew winter was coming. If you saw the Pleiades at dawn, spring was here. If certain stars appeared on the horizon at dusk, the rainy season would begin in 2 weeks. These weren't myths, these were observations verified over hundreds of generations. And they were accurate. Aboriginal Australians used star positions to predict emu breeding seasons, down to the week. Polynesian navigators used star paths to time their voyages, knowing exactly when certain stars would rise and set along their ocean routes. Ancient Egyptians knew that when Sirius, the brightest star in the sky, first became visible at dawn, the Nile would flood within days. This wasn't magic or religion. This was science, observation, pattern recognition, prediction, verification. The first science humanity ever developed, and it was all done with nothing but eyes and memory. Around 1500 BCE, Polynesian navigators did something that should have been impossible. They sailed across 2,000 miles of open ocean, with no compass, no maps, no instruments, and landed on islands they'd never seen before. Some of those islands were less than 20 miles wide. During the day, there was nothing to navigate by. No landmarks, no coastlines, no reference points, just water. But at night, they had the stars, and that was enough, because they understood something profound. Stars don't just tell you when, they tell you where. Every star rises and sets at a specific angle depending on your latitude. If you're at the equator, stars rise straight up from the horizon. If you're at the North Pole, they circle horizontally. Everywhere in between, the angle is different. Polynesian navigators memorized star paths, the exact rising and setting points of dozens of stars. Each star path pointed toward a specific island. If you wanted to sail from Tahiti to Hawaii, you followed the star path of Arcturus. When Arcturus was directly overhead at midnight, you were at Hawaii's latitude. Then you turned east or west until you saw land. But here's what's extraordinary. They also accounted for stellar drift. Because Earth's axis wobbles over thousands of years, star positions slowly change. The North Star today won't be the North Star in 13,000 years. Ancient navigators noticed this, and they updated their star maps across generations. This required generational knowledge, a continuous chain of teaching and refinement spanning thousands of years. One generation would notice a star path had shifted slightly. They'd adjust, teach the new path to their children, who would refine it further. This is cumulative culture, knowledge that builds on itself, that becomes more accurate with each generation. And it only works if you can communicate abstract concepts. If you can say, when that star is 3 hand widths above the horizon at midnight, you'll be at this latitude. Animals can't do this. They can migrate. Birds, whales, monarch butterflies all navigate incredible distances. But they do it through instinct, genetic programming that can't be updated or refined. Humans learned, adapted, improved. And we did it all by watching the stars. Around 3000 BCE, Neolithic humans in Britain began building something extraordinary. Massive stone circles. Some stones weighing over 25 tons, transported from quarries 200 miles away. We call the most famous one Stonehenge. For centuries, people thought it was a temple, a burial ground, a place of mysterious rituals. They were half right. It was a ritual site, but it was also something else. An astronomical computer. The stones aren't randomly placed. They align with solar events, summer solstice, winter solstice, lunar events, moonrise at maximum and minimum points in its 18.6-year cycle, and specific star positions. This level of precision required generations of observation. To build Stonehenge, they needed to know exactly where the sun rises at summer solstice, exactly where the moon rises at its maximum northern point, how these positions shift over the 18.6-year lunar cycle. You can't figure that out in one lifetime. This was a multi-generational research project. Grandparents observed, parents recorded, children refined. And eventually they had enough data to build a permanent marker of cosmic patterns. Once built, Stonehenge became a calendar, a prediction machine. If you stood at the center on the winter solstice, the sun rose through the heel stone. That meant spring would begin in exactly 3 months. Time to prepare for planting. This wasn't religion separate from science. It was religion built on science. They revered the sky because it gave them actionable intelligence. It told them when to plant, when to harvest, when to expect harsh weather. And Stonehenge isn't unique. Similar structures exist on every inhabited continent, all built by cultures with no contact with each other, all precisely aligned to astronomical events. Because everywhere humans existed, they looked up, they saw patterns, and they built monuments to mark what they'd learned. These stone circles were humanity's first scientific instruments, tools for measuring time, predicting events, understanding the universe. Built without writing, without mathematics, without any technology beyond stone and rope. Just observation, memory, and generational knowledge. Today, most humans can't see the Milky Way from where they live. We've conquered the darkness with artificial light, and in doing so, we've lost our oldest teacher. We don't need the stars anymore to tell us when or where. We have clocks, GPS, weather apps.
But for 40,000 years, the sky was our only guide. And in learning to read it, we became something unprecedented. The first species that could predict the future. Not perfectly, but better than any other creature on Earth. We planned migrations before food ran out, planted crops at optimal times, navigated to new territories. All because we looked up and saw patterns. The same stars that guided your ancestors still shine. The same patterns they recognized still repeat. Every night, the universe performs the same ancient dance. We just forgot we're supposed to be watching. But the invitation remains. The patterns are still there, waiting to be seen.